Of the following complex numbers z, which one has the property that z to the 5 has the greatest real part? Okay, so, I mean, my instinct here is to write things in polar form. And, or maybe not just write things in polar form, but plot these numbers and then just try to deduce geometrically where each of them is going to end up. I think I'll start that way. And if I need to actually resort to doing some algebra, then I will. Okay, so the first number we're given is -2, which is here. And -2 to the 5 is equal to -32. Okay, so that's, for option A. And I'm going to work with I'm going to skip to option E because it's purely imaginary and will be a little bit easier to figure out. So option E, the original number is 2i. 1, 2, 3, 4, 5. So 2i to the 5 is equal to 32i, which has a real part of 0. So that in fact means option A can't be correct. So 2i to the 5 is equal to 32i. So that's real part of 0 is winning so far. Okay. -√3 plus I. So -√3 plus I is something like here. Maybe, let's say there. That raised to 5, 1, 2. Oh goodness, I might have to draw some triangles and figure things out here. Let's come back to that one. -√2 plus √2i. So -√2 plus √2i is about here. And it's on like a 45-degree angle, so I should be able to figure out where that one ends up pretty nicely. Okay, so 1, 2, 3, 4, 5. Right? So -√2 plus √2i to the power of 5 is equal to positive √2 minus √2i times $16. Right? And is there a way for me to throw out the other two options? Oh, and one of them is at, so we're at -√3 plus I, and the other one is sort of like right around here. Oh man. I think one of the other two options might end up with a larger real part than this one. That's just my instinct because they're pretty close to each other. But let's man, let's see if we can figure out some triangles and so on. Okay. 3 plus 1 is 4, take square root is 2. So what is this angle? 30 degrees, which is pi over 6. So this is 5 pi over 6. Okay, so this number, negative 3 plus I, this is equal to 2e to the 5 pi over 6. So if I raise that to the 5, I get 32 times e to 25 pi over 6, which is e to the 24 pi over 6 plus pi over 6. Okay, so that's gone, so I'm just at 32e. Oh, I'm obviously missing the I everywhere. E to the I pi over 6. Okay, so that number is over here, right? I mean, it's scaled by 32, of course, but 30 degrees above. I suspect that's going to be the right answer, but I'd like to compute. It's definitely a higher real part than this, right? This one ends up at a 45-degree angle down here, whereas this one ends up at only a 30-degree angle above the horizontal, so it has a slightly larger real part. And the last number, negative 1 plus root 3i, this is going to be equal to so that triangle looks something like this. It's 1 in that direction, root 3 in that direction, and 2. So this angle is pi over 6. That makes this one pi over 3. So this angle is 2 pi over 3. Might help to write this as 4 pi over 6. So this number is 2 times e to the 4 pi over 6i. And if I raise this to the 5, I get 32 times e to the 20 pi over 6i, which is e to the 18 pi over 6i plus 2 pi over 6i, 32 e to the 3 pi I plus, plus 2 pi over 6i. So 3 pi I takes it here, but then we add another 1/3 pi, and we're not even, we end up here. So yeah, my answer is going to be this one, the one that ends up 30 degrees above the horizontal. I raised this, I obviously just forgot to write that this is plus that to the power of 5. I haven't computed exactly what the real part is, of course, but I suppose it'll be 32 times the cosine of that angle. But what option is this? This is option B. Yep. Option B is the one that has the greatest real part after being raised to the power of 5. That is a 5, right? Yeah, okay, so I read it correctly on the screen. Yeah, there isn't much to this one other than, I suppose converting things to polar and just working it out is probably the fastest. Maybe your intuition is good enough for the three numbers listed here to see which one raised to the 5 gives the largest real power, or the largest real part. But you can quickly eliminate this one, of course. Even this one, once you know approximately where these end up. Well, even the third one does end up sort of down here. But yeah, I guess converting to polar is probably the fastest way to do this. And of course, you got to be careful to get rid of multiples of 2 pi in these expressions. Or in this case, I reduced down to 3 pi, so you're way on the negative side of the x-axis. Yeah, if I have a mistake in this one, I'll let you know. Thanks for watching.